So hello everyone. In our previous lecture, we had a discussion over the chemical combinations. In this lecture, we are going to learn about the states of matter and also about the chemical reactions. Okay, so let's start. So what is the states of matter? First question is, what is the states of matter? What is the states of matter? And second one is phase change. Basically, you know about the atom. Atom is basically the building blocks. I had told you that atoms are basically the building blocks. Okay. And when many atoms get combined together, they form some thing. They form some things which we call the matter. Basically, matter can be anything having space and mass. Having space and mass. So basically you can say anything surrounding you, if it's having a space and it's having a mass, then it is a matter. Let's take an example. Your television, your mobile phone, your pen, your air which you are breathing, your water which you are drinking. Okay. So all these things having some space, like your television is around 30 centimeter. Your mobile is about 5 centimeter. Your pen is about 2.5 centimeter. Or you can say also about the 5 centimeter. And the air, there is no space of the air. And then you can say your water is regarding 2 liters. 2 liters. So see, all these things occupying some space. All these things occupying some space. Air also occupying some space, but we cannot calculate it by normal means. Got it? And also these all things having some mass. Like your television, TV in short, may be of 3 kgs. Like your mobile will be of 250 grams. Like your pen will be of 10 grams. Okay. And water is already 2 liters. Water is already 2 liters. Okay. So see, these things occupying some space and also these things having some mass. So that's why we call them matter. And all these things which are different in their shape, size and state, like whether they are solid, liquid or gas, one thing is common amongst them, and which is the matter. So how could a matter decided whether the things would be solid, liquid and of gaseous form? These are the 3 states of matter. And how could an atom decided whether the thing would be solid, liquid and gases? Okay, so let's start this chapter so that we could understand it. Got it? Now let's come forward. First thing is a solid. Solid having some properties, like it is highly resistant. Second thing is it is rigid. Third thing is it is fixed in shape. And all these things are derived from each other. Like first is it is resistant. It can't be changed. Second is rigid. Shape can't be changed. Fixed in shape means it would be broken down. Now let's understand these points. First, solid is rigid. Like if you see, this is a brick. Okay. And you know that bricks are very resistant. Okay. If this brick is in rectangular shape, you can't change it in circular shape, in triangular shape or in square shape. It is not possible to change the bricks from rectangular to these shapes easily. Okay. Second is rigid because you cannot change it because it is rigid. It is in a rigid form. And if you would try to change it, you have to broken it. You have to broken it. Okay. In your childhood, when you were playing cricket, then you must have used this brick to form a wicket. And remember, if this is a brick, sorry, this is a wicket, then besides these wickets, there is a bricks which we used to place to mark the wide line. Okay, so the bowler could drop the ball or could deliver the ball within these lines. Remember? So these bricks which we use are usually of square shape. Square shape. And to get the square shape, what we did, we just broke them from rectangular to the square. Got it? So it is the theory of the solid thing. Now second question is why? Why the solid is rigid? Now the answer is atom arrangement. Atom arrangement. Okay? Because in solid like this one, atoms are very closely packed. Atoms are very closely packed. So that's why it is rigid. And that's why it cannot be transformed into another form except broken down it into two forms. Got it? So it is about the solid. Okay. Now come to the next point. Now it is a liquid. Liquid having some properties also. It is non-resistant. It is flexible. It is rigid than air, basically. Okay. So water is non-resistant, like it has no shape. If you pour the water in the glass, it will be in the glass form. But if you pour it into the bowl, then it will be of bowl shape, or you can say semicircle shape. So it has no shape, so it is non-resistant. And because it could take any shape, so it is a flexible. But it is rigid than air because you cannot see the air around you. Can you? No. But you can see water and you can see liquid, okay, around you because it is rigid than air. Okay. So what about the atomic arrangement of the liquid? Basically, the atomic arrangement of liquid, like if this is a liquid, then it is not so rigid like a solid particle. Like a solid particle, and it having gap between the atoms. Okay. Due to this, it is flexible, or you can say it is non-resistant. Got it? Now come to the third one, which is the gases. Gases are highly non-resistant. Second is highly flexible. Third is can't be seen easy. Okay. Gases are highly non-resistant. They having a no shape. Okay. They are highly flexible. They could also acquire any shape, and they cannot be seen easily. You cannot see the air. You cannot see some gases. Okay. So that's why you can say the gases are totally invisible to the human eye, except some gases, and they are also visible to only humans when they are in large quantity. If they are not in the large quantity, they will not be visible. Got it? So what about the atomic arrangement of the gases? Like if one atom is here, second one is here, third one is here. So here you can say there is a lot of gap between the gaseous atoms. Due to this, it is highly flexible. Got it? Now, let's come to the next point. So basically, it stands for the phase changes. Phase changes. Phase changes always means changing matter state to another form. Shape changes always stands for changing matter state into another form. For example, if we having a solid, then we change it into the liquid. And if we having the liquid, we change it into the gaseous form. Okay? Similarly, if we having a gas, then we change it into the liquid. And if we having a liquid, we change it into the solid. So this process is known as the phase changes. And how does it possible? Then remember one thing. Remember only one thing which will help you a lot in understanding this concept. It is temperature, positive relation with kinetic energy, and kinetic energy, negative relation with intermolecular force. So we had learned that the solid, the liquid and gases, amongst these things, the atoms having some space and having no space, like the case of solid. Okay, so what is the reason why these atoms are combined, get together? Because of the intermolecular force. Because of the intermolecular force. Suppose if these atoms are combining together, so between them it is a intermolecular force. And intermolecular force is the reason why the atoms are combining together. Okay, intermolecular force is highest in solid, thereafter in liquid, and almost negligible in case of gases. Got it? Now come to the kinetic energy. Kinetic energy refers to the movement of particles. Movement of particles. If the kinetic energy of these atomic particles increases, they will start moving here and there, and intermolecular force will be decreased. Okay, and these kinetic energy is increases because of the temperature. So remember one thing here: if the temperature goes up, kinetic energy will be goes up, and there will be a movement amongst these atomic particles. And whenever there is a increase in the kinetic energy, there will always be a decrease in the intermolecular force. Okay, so you can say there are two statements. First statement states that the temperature having a direct proportional relation with the kinetic energy. If the temperature goes up, kinetic energy will goes up. If the temperature goes down, kinetic energy will be goes down. Okay. Second statement is that the kinetic energy having a indirect proportional relation with intermolecular force. If kinetic energy goes up, intermolecular force will goes down. If intermolecular force goes up, kinetic energy will be forced down. Got it? So this is the reason behind the phase changes. Now let's understand. Melting stands for the solid particle. Stands for the solid particle. Okay. If this is a solid particle which we having, so here you can say the atoms are closely packed like an ice. Like in ice. Because ice always produce in the refrigerator, and refrigerator temperature is too low. That's why the kinetic energy presenting by Ke is too low. Okay. But when you put the ice cube outside, then the temperature goes up. And because temperature goes up, so kinetic energy will also goes up. And when the kinetic energy will goes up, the intermolecular force representing by Im will be goes down, and then your solid particle means your ice will start converting into the liquid, means water. Got it? So it is the melting process. Got it? Now come to the next one, which stands for the boiling. Boiling is basically done for liquid particles. Liquid particles. Okay, like here you can see the example of milk, but I will add example of water so that we could understand it better. Like these are the water particles. Okay, when you started boiling the water, again the temperature goes up and kinetic energy will also goes up, and when kinetic energy will goes up, then intermolecular force will goes down and the atomic particles of water started aparting from each other, and slowly this liquid converted into the gas, or you can say water, which is a liquid item, will be converting into the vapors or water vapors, which is a gaseous form. Got it? Now let's move forward. Condensation. This basically happens to convert gaseous item into the liquid. Okay? In this scenario, you have to reduce temperature. Because like in gases, the intermolecular force is almost negligible, whereas in liquid, the intermolecular force is present. Okay, so if the high temperature is there, then high kinetic energy will be there, and if high kinetic energy will be there, then intermolecular force will be low. Got it? So to tackle with this condition, when we started reducing the temperature, the kinetic energy also goes down, and thereafter intermolecular force increases and gaseous item converted into the liquid form. Got it? Okay, now come to the next chapter, which is the chemical reactions. So basically we can say chemical reactions like a magical transformations, because you see two different type of items, but when you react it together, you get some different item, completely different. Okay, and this is known as the chemical reactions. Okay, so in this type we are going to learn about several chemical reactions and related phenomena. Okay, so let's move forward. Like basically in chemical reaction, there is a rearrangement of the things. Most of you in your childhood must play with this Lego box. Remember the Lego box which we have to join together, like this one. Remember? And then the things are built. Okay, so chemical reaction is also like a Lego box where you combine A and B to obtain AB. Like similar in this condition where we combine A and B to obtain AB. Got it? So it is the example of a chemical reaction in a very, very brief and simple manner. Okay, so let's move forward. First thing is a balancing equation. In chemical reaction, or you can say in chemical equations, it is very important to balance the sides. Like A plus B should be equal to AB. Okay, this is known as the balancing equation. And how do we balance the equations? Let's take an example of it. So like here you can see there is a magnesium, then it is a oxygen. They combine together and form MgO. Okay? A, B combine together to form AB. Combine together to form AB. Now notice one thing here. Here O having 2, but here O having only 1. Remember, if there is no number, then it is considered as a 1. Okay. So similarly, here is no number, so we consider it is a 1. So what happened? That the reactant side is not equal to the product side. Because in reactant sides there are 3, but on product side there are only 2. So what should be done to manage this thing? Okay, so we could done multiplication to balance this equation, like MgO2 is equal to MgO. Here we having a 2, here we having only 1, so let's multiply 2 here. Now 2 into 1, O is 2. Got it? But still reactants is not equal to the product. Reactant is not equal to the product. And why? Because Mg here only having 1, but here Mg having 2. So there is no equalization. So what should be done this scenario? Then we should multiply 2 here. Okay. So now we can say 2Mg plus O2 is equal to 2MgO. Got it? So that's how we balance this reaction. Now the reactant size is equal to the product side. Got it? We will have examples of this in our exercises when we will practice them. Till then, just remember this example. Like Mg plus O2 is equal to MgO. Here O having a 2, but here O having only 1. So we multiply 2 so that 2MgO, Mg plus O2 is equal to 2MgO was the reaction. But then we notice here Mg got 2, but here Mg only having 1. So we multiply 2 with Mg, and that's how we balance the reaction. Got it? Now let's move forward. It is the same statement you can say which I have told you. Okay. Now let's move forward. It is the types of chemical reactions. Okay. The chemical reactions which I have told you, it's like combining things together to form a completely new substance having several types, and we are required to learn these types so that we will be able to score good marks in the exam. Okay. So let's start these types. First is a synthesis reaction. What do you mean by synthesis reaction? In basic terms, it is combining several things together to form new one. Okay, it simply means combining several things together to form new one. Like if I ask you to make a dish of potato, if I ask you make a dish of potato, then what all you will require? You will require potato, then you will require a gas, then you will require some water, then you will require some masala, or you can say the spices. Okay. Then you require some special vegetables also, like your pudina and all that. And after combining all these things, you will obtain potato dish. You will obtain potato dish. So did you notice something? Yes. Here, these reactants are several in numbers. It is not a single reactant, several in numbers. But the product which we got in the end is only one. Got it? So basically, synthesis reaction, we combine several things together in order to obtain one single result. Got it? Here is example of baking soda and vinegar. Baking soda plus vinegar. Then you obtain carbon peroxide bubbles. Here also you can see there are two reactants, but the product is single. Got it? Now let's move forward. It's a decomposition reaction. It simply means that if there is something building block, then you divide it into some bricks. It is known as the decomposition reaction, or you can say it's like a magic trick where something big breaks down to small parts. Okay, like you can say it is a common substance ABC, and when we do a chemical reaction, or in simple terms we could see when we do a chemical magic, then we find out there are several products which we got. We put ABC into the chemical reaction and we got A, B and C after the chemical reactions, or you can say a big compound breaks down into the smaller pieces. So this is a decomposition reaction. Like if you put the bread in the oven, this is the bread. After some time you will notice the bread will start dividing into small pieces. Okay, this is because it is a decomposition reaction. Your bread was a big piece and then it started into smaller pieces breakdown. Got it? So it is an example of decomposition reaction. Got it? Now let's move forward. Now it's a combustion reaction. Combustion reaction is like where something burns and turns into ash and smoke. Or basically you can say in combustion reaction, generally there is a fuel which burns and change into several things like light, heat and energy. Like light, heat and energy. Okay. So this is an example of a combustion reaction. Let's take an example into action like which we having here. If it is a candle and we start burning it, okay, then what it will give? This is a candle, and if we start burning it, then what it will give? It will give light, it will give heat, and it will give energy, which we call light energy. Okay, remember I have told you that as per the law of conservation of energy, energy neither be created nor be destroyed. Okay, so before burning of the candle, this is a candle. Before burning of it, it is a chemical energy. But when you start burning, it is a light energy. It is a light energy. Okay, so here you can say the chemical energy, when it will be consumed, it will transfer into light energy, and when the light energy will consume, it will transfer into the heat energy. Okay, and the cycle will be goes on like this. Okay, so it is an example of the combustion reaction. Now let's move forward. It's a single and double displacement reaction. Basically, you can say displacement reaction is like a game. It's like a game where one strong player replaces one weak player. Strong player replaces the weak player. And whenever it is happen, it is the example of a displacement reaction. Okay. So now let's take an example of it. Okay. So suppose if Zn, zinc combined with hydrochloric acid, HCl, then the outcome will be zinc chloride plus H2O. So did you notice something here? Like zinc, Zn, zinc was a strong player. Where in HCl, H was a weak player. And it is the before the reaction situation and it is the after the reaction situation. After the reaction, zinc replaced H from the Cl and combined with Cl, whereas H has to find a different place, or you can say got detached from the Cl. Okay, so it was the example of single and double displacement reaction. Got it? So students, in this chapter we had discussed over the states of matter and the phase changes. Also, we have looked upon the chemical reactions. In our next lecture, we will start stoichiometry and other topics of the chemistry subject. Okay, till then, thank you.